Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers.
When a fiber link stops working, or when testing reveals too much loss in the fiber link, there are several steps that fiber technician can take to troubleshoot the issue. Clean and inspect the fiber connectors and ports, re-terminate the fiber ends, use a visual fault locator, and if all else fails, use an OTDR. Visual fault locators, or VFLs as they are known in the fiber optics industry, are very useful tools for quickly and easily troubleshooting problems in optical fibers. This video will cover some common uses for VFLs, as well as the different classes of VFL on the market. A VFL's primary function is to use the red laser to locate optical faults in the near end of a fiber link, such as in splice trays behind patch panels. However, in certain situations, they can also be used for end-to-end visual fiber identification, especially important when ensuring connector pair polarity, as well as for mechanical splice connector termination. One of the reasons that a fiber link could fail is because the fragile optical fiber is damaged or broken, or has too tight of a bend radius. Thus, it is important to find out exactly where the fault is occurring. However, since most fiber optics communications wavelengths are invisible to the human eye, locating these faults without special sensors is difficult, to say the least. Using a visible wavelength like the bright red laser in a VFL makes troubleshooting much easier and faster, since the location of the fault can be easily and quickly seen by the human eye. Another use for VFLs is visual fiber identification. This means the user attaches the VFL to one end of an optical fiber and looks for where the light comes out at the other end. This is useful for two reasons. First, if the network links are poorly labeled or not labeled at all, the VFL can trace the cable. Second, some testing standards require specific polarity to ensure that transmit on one end of the link goes to receive on the other. The VFL can visually tell the user if the polarity is correct. Finally, some mechanical splice connectors on the market include a small transparent window above the splice point to assist with connector termination. Proper termination is achieved when the red glow from the VFL is minimized or eliminated. There are two classes of VFLs on the market, pen style and traditional. Both can be used for the applications previously stated, but each type of VFL has advantages and disadvantages. A pen style VFL is more or less a laser pointer fitted with a fiber optic connector, which keeps the price down. Pen-style VFLs are not specifically designed for fiber optics, but are nonetheless useful for short-range LAN applications and mechanical splice connector terminations. On the other hand, traditional VFLs, while more expensive, give the best performance because they are specifically designed for fiber optics. You may have noticed with laser pointers that the output power weakens over time, even when a new battery is inserted. This is because red laser material is especially susceptible to voltage surges, especially when a new battery is inserted. Traditional VFLs employ special circuitry that protects the fragile red laser material from voltage surges when new batteries are inserted. This protection circuitry ensures the red laser will not only maintain its brightness over the life of the unit, but will make the unit last much longer than a pen-style VFL. Traditional VFLs are specifically designed for fiber optics due to a special micro-ball lens placed in front of the laser output that collimates and focuses light for optimal coupling into optical fibers, a process that requires expensive high-precision machinery to install the ball lens in exactly the right location. Optical coupling means maximum performance. Several years ago, the first fiber-to-the-home network was being installed in Tennessee, with Dolly Parton's home being the first one to be connected. Our customer needed to put on a demonstration for the governor of Tennessee and was going to use a pen-style VFL when he discovered that the light output wouldn't make it all the way through the network. So the customer used one of our traditional VFLs instead. Because of the advantages of our traditional VFL, he was able to send light through the network for the demonstration.
This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.